Simplifying rational expressions. Rational expressions are basically polynomials that are written in fraction form. So you have p over q, where p and q are both polynomials. And so polynomials are something like what we've talked about before: monomials, binomials, trinomials, and so on and so forth. So some examples of rational expressions would look something like this. So you have a trinomial over a binomial. Here we have a binomial over a trinomial, and here we have a monomial over another monomial. So what we're going to do is we're going to learn how to do some math with these rational expressions or fractions with polynomials. So the first thing we're going to do is we're going to evaluate a rational expression, and to do that, it's just like what we've been doing. We're going to substitute or replace variables with the values that are given into the rational expression, and then we're going to simplify the result. So here we have evaluate the following expression for y equals -2. And so as you can tell, we're going to replace all of our y's with -2. So we're going to have -2 minus 2 over -5 plus a -2. And then doing the math from there, we're going to have -4 over -7, which is going to be 4/7. Undefined rational expressions. So we have to be able to determine when a rational expression is undefined. So remember, when you have a rational expression, you have a fraction. And in order for a fraction to be undefined, the denominator cannot be equal to 0. So a rational expression is undefined when the denominator is equal to 0. So the numerator can be anything that we want it to be. It can be equal to 0. If the numerator is equal to 0, then the whole entire rational expression goes to 0. So, are there any values for x for which each rational expression is undefined? So for this one, in order to make this denominator go to 0, remember, it's asking, are there any values for x for which each rational expression is undefined? So all we've got to do is make that denominator go to 0. And so if we solve this, we're going to get x is equal to -8. So the value that makes this rational expression undefined would be -8. So the expression is undefined when, like I said, x plus 8 equals 0, and so the expression is undefined when x is equal to -8. So here, are there any values for x for which each rational expression is undefined? So we're going to take that denominator, remember, and we're going to set it equal to 0 and see what happens. So again, when we set it equal to 0 and we solve, of course, we're going to minus 45, and so we have 15x is equal to -45, and then of course divide by 15, and you get x is equal to -3. So if x is -3, this is undefined, meaning there's no answer. You cannot do this. Okay, so simplifying rational expressions. This is where we're really going to begin. So we've talked about what a rational expression is. We've talked about how to substitute or how to evaluate a rational expression. We've talked about when rational expressions are undefined, so we know what our answers cannot be, because what we're going to do is we're going to be simplifying and eventually solving for x. So the first thing we're going to do is we're going to simplify. Basically, we are reducing. So if I gave you a fraction of 2/4 and I said simplify, what I'm talking about is reduce. And you remember back in, I don't know, maybe 3rd grade, both of these will divide by 2. And so you get 1/2. That's what we're going to do with these rational expressions. So here are your steps. The first thing you're going to do is you're going to completely factor the numerator and denominator. And then you're going to divide out any factors common to the numerator and denominator. This is the same as removing a factor of 1. So for example, if here you have 2/4 and we're going to divide each one of those by 2. So you know that 2 is of course prime, and then 4 will go into 2 times 2. Well, these two go to 1, and so you get 1/2, and that's essentially what we're doing here. And so that's what we're going to try to do. We're going to take our 2 over 4. We're going to factor it to where it won't factor anymore, which means it's prime. 2 is prime. 4 will factor into 2 times 2. Now that's prime. And then we're going to factor out or reduce anything that cancels out to 1. And so that's how we're going to get the 1/2. So we're going to take this into our rational expressions. So look at this. We have 7x plus 35 over x squared plus 5x. So we have to factor each one of these. Well, going through our factoring techniques, we always look for something in common first. So for the numerator, I know that there's a 7 in common. And if I divide each one of those terms by 7, I'm going to get x plus 5. And then the x plus 5 is prime, so I know it won't go again. Now the denominator, there's an x in common. So if I divide each one of those terms by x, I'm going to get x plus 5 there. So as you can see, we have two factors that are exactly the same. Those will cancel out to 1, leaving me with 7 over x. And we just reduce that rational expression. So let's try this one. On the numerator, we have a trinomial. There's nothing in common. Leading coefficient's 1. And that's not, well, of course it's not a perfect square trinomial. So we're going to open up two sets of parentheses. Our signs are going to be different. And we're going to split our x squared into x and think, what can I multiply together to get 4? But subtract to get 3, and the bigger number has to carry the sign. So I'm going to go with 4 and 1, because 4 times negative 1 is negative 4. But 4 and negative 1 give me a positive 3. Now, for the denominator, same thing. I have a trinomial. My leading coefficient is 1. Open up two sets of parentheses. Again, the signs are going to be different, and I know that because that second sign is negative. Split the x squared into x, and think, what can I multiply together to get negative 20? But add together to get, or subtract rather, to get negative 1, and the bigger number has to carry the sign, so we're going to go with 5 and 4, negative 5 and 4. So now that I've got it factored, I can see that I have two factors that are exactly the same that will cancel out to 1. And so my answer is going to be x minus 1 over x minus 5. Now you may be thinking, why can't we reduce this x over x? Well, if you go back up here, you'll notice that this x minus 1 is a group. And the only way to factor out or cancel out a group is if there's another group just like it. And so here we have 4 factors, 4 different groups. These two groups are exactly the same, and that's why I could cancel those. And you're thinking, okay, but when you come down here, you take them out of parentheses. But they're still a group. So this x belongs to this negative 1, and this x belongs to the negative 5. So you cannot cancel those out. Okay, look at this one. X plus 5. That's prime. It won't factor anymore. And then on the bottom, that's the difference of two squares. So we'll open up two sets of parentheses, plus in one, minus in the other. Square root of x squared is going to be x, and the square root of 25 is going to be 5. Now remember, this is a binomial group, and so that x plus 5 will go away. And remember, when something cancels out, it goes to 1, so I'm going to have 1 over x minus 5 as my answer. Now, another thing that we can bring up at this point is, well, why in the very beginning can I not reduce this x with this x and this 5 with this 5? It goes back to the same concept. That's a group, and that's a group. Not to mention the fact, remember I said for your steps, the first thing you've got to do is factor the numerator and the denominator. Then you can cancel. Alright, look at this one. Both of these are prime, but they're backwards because here I have a positive 7, here I have a negative 7. So what would happen if we wrote this in descending order? Well, we have negative y plus 7 over y minus 7. Notice that these signs are backwards. So we have a negative y and a positive 7 and a negative 7. The easiest way to fix that is to factor out a -1, and you can factor out a -1 out of either one of them. It's just I don't like for my leading coefficient to be negative, so I'm going to take the -1 out of this one right here. So I'm going to have -1 times, and all that does is change your sign, so you'll have y minus 7 on top, and then y minus 7 on bottom. And remember, this is a group, so those groups cancel out to 1, and your answer is going to be -1. So it's a good idea to know that if you see something backwards, like this right here, we can factor out a -1 and turn it around and see what else will factor out. So again, your answer is going to be a -1. Alright, so let's look at this one. Again, we have something that's backwards on top, so we can turn that around, and I'm going to go ahead and factor out a -1 as I turn it around, and that's going to be a x squared minus 4. And on the bottom, we're just going to leave that alone. So all I did was fix the fact that that numerator was backwards by factoring out that -1. So now what I need to do is I need to factor what's left over. So I'm going to bring that -1 along. So here, x squared minus 4 is the difference of two squares. And so open up two sets of parentheses, plus in one, minus in the other. Square root of x squared is going to be x. And the square root of 4 is going to be 2. Now, for the denominator, I have a trinomial. My leading coefficient is not 1. So remember, we have to do bottoms up. My father drinks Red Bull. And instead of messing up my problem, I'm just going to go off to the side and do the work there. So if I have 3x squared minus 5x minus 2, remember, first thing we're going to do is we're going to multiply the first times the last. So we're going to have x squared minus 5x minus 6. And then I'm going to factor. And so the signs are going to be different and split my x squared. What can I multiply together to get -6 but subtract to get -5? And that's going to be a -6 and a +1. And then I'm going to divide the 3 back out. And I'm going to reduce. This first one won't reduce, so I'm just going to bring that bottom up. So we'll have 3x plus 1. But this one is going to be x minus 2. So that's going to be my new denominator, 3x plus 1 and x minus 2. So now I have 5 factors here. I have 1, 2, 3, 4, 5. Which factors are the same? Is that x minus 2. So that's going to go away. So my answer is going to be -1 times x minus 2, I'm sorry, x plus 2, over 3x plus 1.